Yeah. So let's look at the principle of counting. So let's start with a simple example. And that example is a student is to roll a die and flip a coin. I want to roll a die and I want to flip a coin. So how many possible outcomes will there be? I'm rolling a die. You know, if I roll a die, okay. So sorry. Okay. So the principle of counting, like we can see. So in this case now, we have a student is to roll a die and flip a coin. If I roll a die, what are the in rolling a die? Sorry. Okay. So in rolling a die, what are the number of ways?
That's 6.
Number of possible. We want to look at the possible yes, the possible
6.
outcomes. So when you roll a die, so you have 6 ways, 6 different outcomes. Now, when you flip a coin, this is for die. For coin, when you flip a coin, how many outcomes? We have 2 outcomes, Abi. Is either a head or a tail. So in this case now, they say how many possible outcomes will now what will happen? Do we have when a student is to roll a die and flip a coin? So what do you think we can have as our answer here? I have 6 outcomes for this. I have 2 outcomes for this. So what's the total number of outcomes for the 2? Any idea? Any idea? Can we say 4 or 2 or 6? Or sorry, 4, or let me look at the possible answers. We may want to guess and say, okay, if you guess, we may have a 4. We may add together. When you add together, you get 8. When you multiply,
8.
you get what? You get 12. When you say 1 raised per the other, maybe 6 raised per 2, you get 36. When you say 2 raised power 6, you get 64. If I'm an examiner, I'm going to put those answers. If it is objective question, I will put all those answers there, so that whichever guessing you conclude that you find all your answers there. So, but in this case, what we have is that when the principle of counting is that when you can do things in different ways, then when you now want to do it together, then it will be what? Multiplication. So the number of ways you can do this will be what? 2 times 6. And that is what? That is 12. Let's look at the practicability of it. For a die, we have 6. Okay, we can start from a die itself. A die, if it is a die, let's use tree diagram. You can have 1, you can have 2, you can have 3, you can have 4, you can have 5, you can also have 6. Now, having done that, let's assume that our answer is 1. When you flip a coin, you can either have what? Head and tail. So meaning that you can have 1 for the die, head for the tail, head for the coin, or 1 for the what? 1 for the die, tail for the what? So those are 2 different ways that you can get. Let's move on. Let's assume that your die outcome is 2. So we can have what? Head, tail. So making 4 combinations now. 1 and head, 1 and tail. 1 and head is a combination. 1 and tail, another combination, making 2. 2 and head, making 3. 2 and tail, making 4. So we have 4 now. let's go on. You can also have what? Head, tail. So if I pick 3 head, 3 and head, that's what? 5. 3 and tail, that's 6. I can also have it like this. I can also have it like this. And I can also have it like this. So in all, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the answer to that. I hope it's very clear. Okay, so that is what you mean by principle of counting. Let's apply it to question number 2. It said there are 5 different routes from your house to the school. And there are 3 different routes from the school to the market. So how many different ways can you go from your house to the market via the school? So you get it. So via the what? Via the school. So meaning that we may have what? 5 different from your house to the school. So from your house to the school, we have 6. And from the school to the what? From the school to the market, we have what? We have sorry. I have 5 here. And here you have what? You have 3. So what do you think the answer will be? So how do you, if I want to go from my house to the market via the school, I have to go through the school. I'm not going directly. I have to go through the school. So in how many possible ways? So using the principle of counting, very straightforward. It's very straightforward. From year to year, you can do that 5 ways. From year to year, you can do that 3 ways. If you are doing both, it means it will be what? 5 times 3. That is what? 15 ways. So that's the principle of counting. That if there are, so meaning that if from A to B, so the general principle of counting is now that, for example, if I'm having, I can do A in n number of times. I can do B in m number of times. I can do C in what? In mn, maybe p number of times. I can do D in what? Q number of times. So in how many ways can I do A, B, C, and D? So it means it will be n times m times p times q. So that is just the general principle of counting. Anytime you are counting, you want to do anything, I can do this one in this way, I can do this one, and I want to do all of them together. So it will be n times m times p times q. So that's in simple term. That is what you mean by principle of counting. So let's move to the next area. Now, so there are more problems here. You say for a college interview, Robert has to choose what to wear. So in choosing what to wear, from the following, we have 4 slacks, 3 shirts, 2 shoes, and 5 ties. So how many possible outfits does he have to choose from? How many possible outfits does he have to choose from? So he's wearing everything. He has slack, he has 4. For shirts, he has 3 different ones that he can wear. For shoes, he has 2 different ones. For tie, he has 5 different ones. So how many possible outfits does he have? He's using all. It is all. So I believe you should be able to do this. Is there anybody that cannot do this? What's the answer?
120.
120. Yes, 120 is correct. 120 is correct. So 120 is correct. Yeah, so just multiply 4 times 3 times 2 times 5, and that will give us 120. So that is the solution to that one. Let's move to the next one. Okay. Now, so as a result, one will say that what? A permutation is an arrangement. So what do you mean by a permutation? Is an arrangement of items in a particular order. That's what we mean by permutation. Arrangement of items in a particular order. So you have to take note that order matters in this case. Order. The order of what I mean by order. Look at it. I may say I want to arrange in how many ways can I arrange the letters? Look at here. Look at this question. In how many ways can the letters of the letters A, B, C be arranged? A, B, C be arranged. So if I need to arrange the letters A, B, C, A, B, C, this A, B, C is still different from what? C, B, A. They are the same letter. They are the same letters, but the arrangement is different. So CBA is different. I can also have BCA. I can have CAB. I can have BCA. I can have BAC. I can also have what? ACB. So these are the different arrangements that we can have. So you may be asked, in this case now, because it is very the small number, I just have just few numbers, just ABC. So it's very easy for me to do it manually. So I think these are the 6 possible ways. There's no other way you can also do anything again. These are the 6 possible ways. So in this case, it is very easy. So that is why we have been able to get it like this. But in another case, it may not be all that easy. So how do you want to do that? So that is the concept that we want to learn. So they also said that to find the number of permutations of n items, we can use the fundamental counting principle like I explained the other time. We can use so the way we can do this, we can use fundamental counting principle. I'll teach us how you can use that. At the same time, we can also use the principle of factorial, which I'm also going to at least take us through. What do we mean by factorial? So I'm going to take us through that one too. So from this, you can note this now. These are the answers. This is the answer. We have 6 ways. But they did not require us to list out those possible combinations that we may have. So we don't actually need this combination. I just at least use this so that you can understand what I'm trying to say. So the major thing is that you should be able to determine the number of ways we can do it. Now, for me to use principle of counting on this particular question, in how many ways can the letters of the word ABC, can the letters ABC be arranged? So for me to use that principle, what I just need to do, I need to, let me create a box such that I want to wrap their space. This is the space for the first digit, first letter. This is the space for the second letter, and this is the space for the third letter. Now, how many letters do I have? I have A, B, C. So if you want to use the principle of counting, what will just happen is that, okay, I have 3 letters. How many options do I have to fill this first box? I'm filling it in this order. I'm filling it in this order. How many ways can I fill the first one? What I mean is that how many letters can I put in the first one? All the 3 I can put. I have 3 letters. All the 3 I can put. So I have 3 ways. So if I've put one of the letters, I don't want to know which one I have put. It could be B that I have put there. It means I'm left with how many letters? 2 letters. So for me to fill the second space here, I have two options. I may pick any of the two remaining ones. So I have two ways. So if eventually I pick C, for the third one, for the third letter, I don't have any option than to just pick the remaining one. So I have just one option left. So it means I have three ways of filling one. I have two ways of filling two. I have one way of filling three. So as a result, how many ways, how many options do I have to fill all? According to our principle of counting, it says we must multiply them. So we have 3 times 2 times 1, and that is 6. So that is how we can do that. The second question says, in how many ways can 5 people be arranged in a row? In how many ways can 5 people be arranged in a row? It means I also have to create the space of those people. The space I want to I want to arrange them. I want them to stay. So if this is the space, so let me create their space. I have 1, 2, 3, 4, 5. Yes, there are 5 in number. 1, 2, 3, 4, 5. I've created their spaces. So in how many ways can 5 people be arranged? Now, if I'm the one to arrange them, for example, I say we are line up. So let me look at it. I will be thinking, who should I put in the first position? Who should I put there? Okay, I can put this, I can put this. If you look at it, I have not less than 5 options. So if they ask me how many options do I have 5 different options of filling this place. So you put 5 there. For the second person that I want to put, if I put 1 out of the 4, it means I'm going to have how many people? I'm going to have 4 left. So any of the 4 I can put here. So I have 4 options of filling the second space. If I have eventually picked one of them again, so it means in all I've picked 2. I'm left with 3 people. So to fill the third position, I have 3 options. So eventually I picked one person to put to what? To occupy that place. So it means I'll be left with 2 people. So for the fourth position, I have any of the 2 persons can be filled. So I have 2 ways there. So I'm going to have just 1 person left. So for the 1 person, I can put anybody here. So that would be what? 5 times 4 times 3 times 2 times 1. And that is what? 120. So I have 124 ways in which I can arrange 5 people in a row. So that's how we can do that particular question. I hope you are getting it. So let's move on. So that is how we can use the fundamental counting principle. But if it is the principle of factorial, I'm going to explain factorial to us in the next slide. But to use the principle of factorial here, it means in how many ways can the letters A, B, C be arranged? So A, B, C, I'm arranging those 3 letters. So we say that I'm arranging 3 out of 3. We call it 3 permutation 3. So I'm going to give us the principle of permutation. And then 5 people. Since we are arranging 5 out of 5, it will be 5 permutation 5. So take note. Actually, 3 permutation 3 will give us 6. We are going to look at it. 5 permutation 5 will also give us 120. We are going to look at it in the next one. So that is how we can do it. Now, so let's move on to. So this is the concept of factorial. When we say n factorial, it means we are multiplying from n, product of n down, all numbers from 1 to n, all consecutive, the product of all the consecutive numbers. from 1 to n. That's the meaning. For example, 5 factorial. The product of numbers from 1, all consecutive numbers from 1 to 5. So that would be 5 times 4 times 3 times 2 times 1, which is what? 120. 7 factorial. It means the product of numbers from 1, consecutive numbers from 1 to 7. So another thing that we also need to note here is that we can actually, we may not need to, it's not all the time that we need to take it to 1. If you are not stopping at 1, we must stop at a place where we are going to put 5 factorial. For example, the 4 factorial that I did earlier, I may say that 4 factorial is still the same thing as 5. So 5 factorial is the same thing as 5 times 4 factorial. If I so wish to stop at 4, so I can have it as what? 5 times 4 factorial. So it depends. So that's why I stopped this. So anywhere you are stopping, if you are not stopping at 1, anywhere you are stopping, you must ensure that what? You stop with factorial. You must put factorial there. Okay. So, okay, all right. So you must ensure that you put factorial there. So that is one thing that you need to take note. Now we want to simplify this. Simplify could just be that you may not need to get the final answer. They just want you to simplify and see if. So in this case, when you are simplifying, for example, 5 plus 4 factorial, it's still the same thing as you can just break it down. 5 factorial is the same thing as 5 times 4 factorial plus 4 factorial. So in that case, 4 factorial is common. It's just like we are factorizing. So here we are left with what? 5. Then here you are left with invisible 1. So the same thing as what? 4 factorial times 6. 4 factorial times 6. They may not want you to get the actual answer. They may not require you to get the actual answer. So, but at least you should be able to simplify factorial. So that is the answer to that particular one. So it could also be 7 factorial plus 5 factorial. So you should be able to do that too. So just break whichever that is greater, break it down to the level of the smaller. So that is what you need. Looking at this one too, 7 factorial, that will be 7 times 6 times 5 factorial minus 5 factorial. So what is common? 5 factorial is common. 7 times 6, 42. Minus 1. So invisible 1 here. So 42 minus 1 is 41. So you can have it as 5 factorial multiplied by 41. So it's very evident is in those ones that that are quotient. So like number 4, look at number 4. 8 factorial over 6 factorial. It's still the same thing you do. You reduce the greater to the level of the smaller. So which one is the greater here? 8 factorial. So if you have to reduce it, 8 times 7 times 6 factorial. Stop at 6 factorial divided by 6 factorial. So 6 factorial cancels 6 factorial. 8 times 7, that's 56. So that is what you mean by that. So you can also have n factorial over 2 minus n minus 2 factorial. Okay, let me do that one. I will stop at number 5. So I expect you to go and try the rest. For number 5, it's the same principle. N factorial over n minus 2 factorial. You ask yourself, which one is the smaller of the two? Which one is greater of the two? So you reduce the greater to the level of the smaller. The greater is n here. So what is the number that follows n? The numbers immediately before n. That will be, if you look at this, how did I get 7 from 8? To get my 7 from 8, what do I do? I will say, don't tell me m, don't tell me m. Some people will just say n times m. No, you look for the next number. How do we get the next number or the number before it? Just say 8 minus 1 will give me this. 8 minus 2 will give me this.
That's n minus 1.
So you use that principle like that. So you have n minus 1, n minus 2. Yes, we are going to n minus 2 because n minus 2 is down. So anywhere you are stopping,
Factorial.
you put factorial over n minus 2 factorial. So they are the same thing. So it means our answer is what? N multiplied by n minus 1.
N.
So that's the answer. You can leave it like that. You may say n squared minus n. So whichever one. So that's the solution to that particular one. So let me leave you to play around with remaining questions. So let's move to the next concept. So based on this, what do we now mean by permutation? We have explained permutation is the arrangement of what numbers or items in a particular order. So, and we made mention of, if you need to arrange n numbers or r numbers out of n, sometimes you may not need to arrange all the numbers. I may have 5 people and I only need 3 persons to take a photograph. So in that case, you may be asked that, in how many ways can 3 people be arranged out of 5 to take a group photograph? So in such a case, it means that we are arranging R out of N. We are arranging R people out of N people. So the formula is what? If you now want to use the formula, so the formula for that permutation is what? N permutation R equals to N factorial over N minus R factorial. So since we have learned the concept of factorial now, it will be very easy for us to apply this formula. So which we are going to use in the next slide. We'll see the formula self in the next slide. So this is the formula. N permutation R equals N factorial over N minus R factorial. So that's the answer, that's the formula for that. So there's a question here. It says a combination lock will open when the right choice of 3 numbers from 1 to 30 is selected. How many different lock combinations are possible, assuming no number is repeated? So it's like they have a lock, and then that lock, maybe it could be a lock like this, and it has 3 holes. So a lock can be just so those numbers are just like a key to open such a lock. So, and they said that for you to open it, it means you must go for a right choice of numbers. So if you put those right choice of numbers there, so they say how many different lock combinations are possible, assuming no number is repeated. So how many different combinations can be possible in this case? So it's just the same. You can use the principle of counting. You can also use your permutation. If you are using the principle of counting, we have how many numbers from 1 to 30. So what they are asking here, they are not asking of the correct answer. The correct key to unlock or to open such a lock. They are just asking you, in how many different ways can we have it? How many different ways? Out of how many those different ways, it will now be just one that will work. Get it? and that one is just the only correct one. It's just one that will work. But they're asking how many different combinations are possible. So what you have to do that, for the first one, since we have 30 numbers, so all the 30, I have 30 different choices of what? Filling this. I have 30 different choices. So if out of those 30, I've picked one, I have 29 left. So to fill in the second this thing, I have 29 different options. For the next one, I have 28 different options. So my answer will be what? 30 times 29 times 28. If I'm using the principle of permutation or the principle of factorial, so for factorial, it means what do we do? For factorial, if you are going to use for factorial, okay. So for factorial, what do we do? It will be, since we have 30 different combinations, 30 letters or 30 digits, we are picking just 3. We need 3 out of the 30. That will be 30 permutation 3, which is 30 factorial over 30 minus 3. That's 27 factorial. So if you do that, sorry. Okay, so if you do that, according to what we have learned in factorial, which one is greater? 30 is the greater. So you reduce it, 30 times 29 times 28 times 27 factorial up to 20 divided by 27, because this one is 27. So you can see that we have the same thing, 30 times 29 times 28. So that's the solution to that particular question. The next question here, they say from a club of 24 members, a president, secretary, treasurer, and historian are to be elected. In how many ways can the offices be filled? We want to fill the office of the president, the office of the secretary, the office of the treasurer, and the office of the historian. So how many offices do you want to fill? We are filling 1, 2, 3, 4 offices out of 12 members. So in how many ways can the offices be filled? So can somebody assist us there? Can somebody help us out? Precious, can you help us out? Question number 2. Can you help us? Is there anybody that wants to help us here? Amin. So, okay.
Can I?
Okay, so who is assisting us? Farida, Precious. So who want to tell us, who want to do that for us? Do we have any to do that for us? It's very simple now.
It will be 24 factorial.
24 factorial?
Yes, and you have 24 minus 4 factorial.
Okay, 24 minus 4 factorial. That's it means you are trying to say that we have 24 permutation 4.
4, yes.
Is that what you are trying to say?
Yes,
yeah.
yes.
Yes, that's correct. 24 permutation 4 is correct. 24 permutation 4. Now, that's the way you use the principle of permutation. If you use the principle of counting, If you use the principle of counting, you can leave this place for the president, leave this place for the secretary, leave this place for the treasurer, and leave this place for the historian. So you may want to start from the president. Whichever one you are starting from is the same thing. So if we have eventually picked, we have 24 ways of filling the position of the president. So if eventually we pick somebody from the president, such a person cannot be picked as the secretary again. So we have just 23 ways to fill the secretary position. If you have picked somebody from the president and the secretary, for treasurer, you can just have just 22 ways of filling it. You have 22 people left. If you have also filled that, for the this one, you have just 21 persons left. So that is how you can do that. So we just multiply 24 times 23 times 22 times 21. So whatever you get is your answer to that particular one. Yes, 24 permutation 4. Okay, so the next question, find the total number of different arrangements using any three of the three letters of the word chemistry. Chemistry. So find the total number of different arrangements using any three. We need any three letters. We want to pick any three letters. Out of how many letters do we have in the word chemistry? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 letters. So, sorry, we have 9 letters for that. So how do we do that?
9 permutation 3.
That's what?
9 permutation 3.
9 permutation
3.
Yes, 9 permutation 3. You are right. 9 permutation 3. So since we have just 9 letters, we have 9 letters, we want to arrange 3. Yes, very correct. How many 4-digit numbers can be formed using the digits 1, 2, 3, 4, and 5? How many 4-digit numbers can be formed using the digits 1, 2, 3, 4, 5? So how's the answer to that? How many 4-digit numbers?
5 permutation 4.
5 permutation 4.
5 permutation 4. Yes, you are correct. We have 5 letters, 5 numbers in all, 5 digits in all. So we want to what? We want to arrange just 4. So that's the correct answer to that. That's very great. So let's move to the next one. So arrangements including identical objects. If you look at those ones that we have done, we have not actually talked about identical, those ones that are identical there. So in how many ways can the letters of the word maximum be arranged in order?
7 permutation 5.
7 permutation. Okay.
5.
Okay. 7 permutation 5. Okay, let's examine that. How many letters do we have? 1, 2, 3, 4, 5, 6, 7. Okay, why do you now say permutation 5? Is there in how many ways can the letters? All the letters is all the letters that we are arranging. So why have you chosen 7 permutation 5?
Because the 3 M's are the same thing.
Okay, 3 M's are the same thing. Okay, yes, yeah. Now, thank you for that. Thank you for that observation. Now, when you see such a thing, actually, we are arranging all. So it will still be 7 permutation 7 for the fact that we are arranging all. But for the fact that those letters are what? They are the same. Take for example now, if I exchange this M and this M, if I put this M here, I put this one here, and I put this one here, will it make any difference? It won't make any difference. You see the same maximum that I have. I can also exchange, do the same thing here. So what will now happen is that it means we are going to have duplications. We have duplications. So in order to take care of those duplications, what do we do? So that is what we are, how do we tackle those duplications that we are going to see? So that's the major thing that we need to address. And how do we address that? So you look at the number of possible duplications. Now in this case now, I have M 3 times. Is that clear? So it means I'm going to divide my answer for 7 permutation 7. I'm going to divide it by this particular what? 3 factorial. Let me take let me use a practical example for you. Let's assume that we have okay, yes. This one, let's see, will it make sense? Yes. Okay, look at this. I don't want something that will be too long. Yes, 5 times 4 times. Okay, I think this one won't be long. Look at this. 2, 2, 3, 3, 3. If I'm going to have it, I'm going to have 2. I can have 2, 2, 3, 3, 3, like that. Exactly. So another way I can also have it is to have 2, 3, 2, 2, 2. Sorry, 2, 2, 3. This one will be 2. I don't want something that will be, we are going to have, we should have 10 different combinations. But let's leave that. Let's look at AB, ABA, for example. You can see that A occurred 2 times. So I can have it like this, ABA. I can have it like this, AAB. And I can also have it as what? BAA. Is there any other option here? Do I have any other option? Is there any different, another combination that I've not written? I don't think so. So in this case, how many letters do I have here? 3. So it is, I'm arranging all the 3 letters. But because of the fact that there is something there, A occurred 2 times. So it means I'm going to have 2 factorial repetitions. It will be 2 factorial repetitions. So I need to divide by 2 factorial. N permutation, 3 permutation, 3 will give me 3 factorial. So if I divide by 2 factorial, it will later give me 3 times 2 factorial over 2 factorial. And that will give me what? 3. So that's why I have 3 here. So anytime you see something of such, you have to divide by the number of combinations. Those ones that are repeated. So that is what you are going to do. So in this case now, like we have said, we have 7. So it will be 7 permutation 7. 7 permutation 7 is same thing as 7 factorial. Yes, there's something that I failed to mention. Sorry for that. Sorry about that. 7 permutation 7 is same thing as 7 factorial. Then 7 minus 7 is what? 0 factorial. Yes, I failed to mention 0 factorial. 0 factorial will give us 1. We may not be able, this class may not be, we may not have the room in this class to prove that for us. But at least for students of mathematics or engineering whatsoever, in our institution, you still do something of such, factorial function. So there you can prove why 0 factorial is equals to 1. That's the concept that is too big for the class, for this particular class to discuss. So the concept of factorial function. So in that case, you can prove with that 0 factorial is actually 1. So 0 factorial is 1. So 7 permutation, 7 is 6 as 7 factorial. So in this case now, for maximums, you say that what 7 factorial divided by what? Divided by how many different repetitions? M, M, M. That's 3. So divided by 3 factorial. Is there any other number any other letter that is repeated? No other letter is repeated. So our answer is 7 factorial over 3 factorial. You can break that down. Whatever you get is the answer. 7 factorial over 3 factorial. So we also have the letters of the word statistics. So can you number it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be what? 10 divided by what are the different combinations or different letters that are repeated. X is repeated how many times? 1, 2, 3. 3 times. T is also repeated. T is repeated how many times? 1, 2, 3. Also 3. A is not repeated. I is another thing that is repeated. How many times? 1, 2. So 2. I think those are the different letters that have been repeated. C is not repeated. So you are going to say divided by 3 factorial, divided by another 3 factorial, and divided by 2 factorial. Because these X that are the same thing, if they are not identical, it will have been arranged in 3 factorial number of ways. If these ones too, C are not identical, it will have been what? So you have to remove them. Just like the reverse of the principle of counting. The principle of counting, you are going to what? You multiply them. But you need to remove those ones here. So when you remove, it's like you are reversing the principle of counting. So you divide. So 10 factorial, 3 factorial. So I believe you should be able to do the rest. Abracadabra. In how many ways can you arrange the letters of the word? In how many different numbers of 5 digits can be made using the digits 2, 2, 3, 5, 3, 3, 3? You can see that these ones too. This one too, they are what you call you can see that they are repeated. Exactly. So what you just do is that how many now digits do we have? 1, 2, 3, 4, 5. That's 5 permutation 5, which is 5 factorial. Exactly. You now divide by the repetitions that we have. The repetitions. So 3 is repeated 3 times. That's 3 factorial. 2 is repeated 2 times. That's 2 factorial. So 5 times 4 times 3 factorial divided by 3 factorial, then times 2 times 1. So 3 factorial, we cancel 3 factorial. 2 here, 1, 2 here, 2. So 5 times 2 is what? 10. So that will give us 10. It means we can have 10 different numbers using the letters. So that is how you can do that too. We still have a lot of things to cover. So then we also talk about when you have conditional permutation. So you may be given different conditions. Look at examples, what you have here. Say find the number of ways in which the letters of the word shallow be arranged. If the two L's must not come together, then if the two L's must come together. Now, in this case, you may even, there's a particular option that I did not include here. The first thing is that in how many ways can letters of the word shallow be arranged? If you are asked a question like that, without putting any of these two conditions, in how many ways can that be done? You should be able to know that. So can anybody bail me out there? Can anyone bail me out there? In how many ways can the letters of the word shallow be arranged? Just forget those conditions. So how do we arrange? In how many ways can they be arranged? Shallow.
7 factorial.
7 factorial. And that's all. 1, 2, 3, 4, 5, 6, 7. 7 factorial. Is that all?
7 factorial over 2.
Over 2 factorial.
Very good. Over 2 factorial.
Factorial.
Because L
Factorial.
occur twice.
Twice.
So identical objects. So over 2 factorial. So that's the answer. But now they now say if the two L's must not come together, we don't want the two L's to come together. So what we can do in that case is that we have to split such question into 2. How do we do that? I will tell us different ways in which you can do. So you just pick the one that you find very convenient for you. Now, one thing, a way of doing it is that remove those ones that those conditions. So in this case now, L is the major issue. So if you remove L, what do you have? I have shall. So in how many ways can I arrange this?
5.
1, 2, 3, 4, 5. That's 5.
5
factorial, Abi? 5 factorial. Now, what you now do is that if I've arranged this, I will first arrange this. Since they have said that the two L's must not come together, what I will now do is that I now have the option of what? Inserting L in any space left now. It means that shallow, I will just leave space. I can have space. Shallow, I can have space. There's space here, 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 there's space here. I can put any of those L here in those spaces that I've created. You get it? I can say, yeah, you go and stay at there, go and stay here. I won't arrange these ones, shall. I won't arrange them. I may now say, do yes, the remaining L, the 2 L's. Oh yeah, you come and stay here. I also have, it can also stay here, it can stay here, any of, so how many different ways can I put the first L? The first L, I can put it here. 1, 2, 3, 4, 5, 6. Exactly. So the first L, I can put it in 6 ways. If eventually I put the first L here, how many spaces do I have left for the second L? I have 5 times 5. But you know what? They are identical objects. Definitely there will be repetitions. Exactly, because they are identical objects. So the L I put here, if I exchange it with the L I put here, at the end of the day, there won't be any difference. So there are 2 numbers. Exactly. There are 2 numbers. So it means you have to divide it by 2. 2 identical numbers. So in all, I've done 2 things. The first thing I did, in how many ways can I arrange the word shall? I've got 5 factorial. The second thing, in how many ways can I insert N in between them? I've got this. So according to the rule of what? Rule of counting. It means I'm going to what? I'm going to multiply the 2 answers together. 5 factorial multiplied by 6 times 5 over 2 factorial. So what will that answer be? 5 factorial is 120. Then here, 2 here 1, 2 here 3. That should give us 15. So 120 times 15 should give us what? That's 1,800. Yeah, 1,800. I hope you get that. Anytime you are
Yes,
given
sir.
such question, you will just isolate those ones that they have given you as condition. Take them out. When you take them out, deal with others. Then those spaces that you have, you can always, that is if they must what? Be separated. Exactly. So that is one way. I will teach you the second way before the end of this class. Let's go to the next question.
Please,
If the two
the 2 factorial
yes,
that you divided with, how did you get that?
yes, I told you that they are identical objects.
Okay.
L. You can see what we did, the way we dealt with statistics. Abracadabra, and so on in the last example, in the last slide. You know, we are saying that we are going to divide by the number of those letters that are what? That are repeated, that are identical. Because eventually, by the time you what? You replace, if I swap the L here with the L here, it doesn't make any difference. So it means I have repetition. I have repetition. So that's what has happened there. Okay. So now, if the letters must always be together, now for the word letters to be together, you now come back to shallow. For the letters to be together, the only way you can do that is what? To what? Make them to what? Tie them together. Let me tell you here that for the S to be together and for the S not to be together, when you add your answers together, it must give you no condition. No condition that we did this one. No, this one is no condition at all. In how many ways can J just be arranged? 7 factorial over 2 factorial. What do we get here? 7 factorial should give us 7 factorial should give us 5. Is it 5? Yeah. That's 720 times 7. 6 factorial is 720. 720 times 7 divided by 2. So that would be 360 times 7. So what is 360 times 7? That should give us 0, 6 times 8, 42. 3 times 7, 21 plus, that's 2520. Okay. Now, the one we are doing now, when we had the answer to this 1,800, it must give us the same thing. Let's see. So how do we do it? Anytime they tell you that something must be together, the best approach you can use is what? Tie them together. So if I have to tie this L together, so that when I move one, the other will follow it. So if I need to tie them together, it means they will now become one. So how many letters do I have? It means I will now have 1, 2, 3, 4, 5. I now have 5 letters because I have tied them together. No, sorry. 1, 2, 3, 4, 5, 6. I have 6. O is ID there. 1, 2, 3. L, the 2 L will become 1 letter because you have tied them together. O, W. So meaning 6. 1, 2, 3, 4, 5, 6. In how many ways can I arrange those 6 letters? That would be 6 factorial. Exactly. Now we now go back to the L. In how many ways can I arrange those L? But because they are the same thing, I can only arrange it in just one way. Exactly. Because they are the same. Assuming I have L and E now, it means I can arrange it as LE or arrange it as EL. You get it? LE or EL. But because they are the same thing, it will still be LL or LL. So you are just repeating it, repetition. So I can only take 1. So times 1. Exactly. So by the time you add it together, if I add it together, 6 factorial times 1 will give me 6 factorial. That is 720. So in how many ways can they be arranged so that if the two ends must be together, that's 720. If I add 720 to 1,800, will you give me 252? Yeah, it should give me 1,800 plus 720. Yeah, it will give me 2520. So you can see now I've used two different concepts. That's why I said you can use it in two ways. If I've done this one first, I may say the answer of the second one is 2520 minus 1,800, which will give me 720. I don't need to use this principle again. If I use this principle for they must be together, if I have done that first, I don't need to use this principle again for they must be separated. I just need to go and subtract from the total number. So I hope you understand how they can be separated and how they can be what? They can be together. And the fact that togetherness and being separated, when you add them together, they are what? They are exhaustive. They are mutually exhaustive. It means they will give us, they will add up to give us without condition. So that is, let me pause a little bit here and take our comments. The principle of factorial or the principle of permutation combination is very, very wide. I'm just trying to ensure that at least we cover larger percentage of the concept. So if there is any problem, any challenge, any question, let me welcome our question. I still have a lot to treat. So if there's any question, but if there's no question, I may need to move on. So no question. Okay, so if there's no question, let me move on. So I've explained question number one. Question number two, you say how many numbers greater than 3,000 can be formed from the digits 2, 3, 4, 5 without repeating any of them? Wow, this is a great question. How many numbers greater than 3,000 can be formed from the digits 2, 3? Okay, so I think I have one there. 1, 2, 3, 4, 5. Now, if you look at it, I have 1, 2, 3, 4, 5. So those are the different things that I want to. So in this case, look at it. I'm looking for a number that is greater than 3,000. 3,000 is a 4-digit number. And I have 5 numbers. So it means all those numbers, I can have 4-digit number. I can also have what? 5-digit number. Exactly. Since they have said it is greater than 3,000. For example, now if I have 3, 1, 2, 4. Yes, it's a 4-digit number. It's greater than 3,000. I can also have a 5-digit number. If I need 5-digit number, I have 1, 2, 3, 4, 5, for example. It is greater than 3,000. This one is 12,345. So how do I do it? I will first create a chance for 4-digit number. I will also create chance for what? 5-digit number. Now for 4-digit number, not just any number that I can pick for 4-digit number. For 4-digit number, it means one cannot start such a number. If I need 4 digits, for example, now if I need to rearrange this as 1, 2, 3, 4, you know it's not greater than 3,000. Or if I have chosen 1, 4, 2, 3, it's not greater than. So it means that in that case, I need to in choosing the first letter or the first digit. I can't just pick any letter, any digit there for the first one. So for the first one cannot start if it is 4 digits. Exactly. So I'm considering 4-digit number. Let me put 4-digit number here. 4-digit number. And this space for 5-digit number. So for 4-digit number, the TV cannot start. So I need to sort that one out before I use my permutation. TV cannot, 1 cannot start, 2 cannot start, but TV can start. Like TV 124 is greater than 3,000. So TV can start, 4 can start, 5 can start. So it means to fill in the first digit here, first position, I have 1, 2, 3. I have 3 ways of filling that. I have 3 ways of filling that. Please, just a minute. Let me quickly sort out power. Okay, don't worry, let me continue. I may have to switch. It's just that it will affect, it may affect, so let me just continue. So, so from this now, I say I have 3 ways of filling the first cell. Listen. So for others, for other letters, other digits, 1, 2, 3, it means I haven't sorted the issue of the first digit. I need to sort the remaining 3 digits. So 3 ways for picking the first one. For the remaining digit, I have 1, 2, 3. Out of, if eventually I've picked 1 out of these 3, it means I'll be left with 2 out of these 3, and I'm left with extra 2. So making a total of 4 numbers. So, and I need to pick 1, 2, 3. I need to fill 3 positions. So in that case, it will be 3 ways times 4 digits left, permutation 3. Okay. Oh, yeah. Okay. Yeah. Great. So I hope you get that. So in that case, it will be 3 ways multiplied by 4 permutation 3. 3 ways, 4 permutation 3 is 4 factorial over 4 minus 3. That's 1 factorial. 4 factorial is what? 24. 24 times 3. That would be 72. So it means that for 4-digit number, I can have 72 ways. If it is 5-digit number, any number can come. I don't need anything. So that would be 5 permutation 5. And 5 permutation 5 will give us 120. So, and I've said it is either 4-digit number or 5 digits. Anytime you use or, it is addition. And the fact that they are exhaustive, it is either this or this. Exactly. So we can have 4 digits. You add whatever I get for 4 digits to whatever I get for 5 digits. So that's 120. So the total answer is 120 plus 72 ways. That is 192 ways. I hope you understand that. Let me come again. Let me come again. Say find the number of ways in which the letters of the word, say how many numbers greater than 3,000 can be formed from the digits 1, 2, 3, 4, 5 without repeating any of them. So I said what you just have to do there is that we can have, because of the fact that it is greater than 3,000. 3,000 is how many digits? 1, 2, 3, 4. 4-digit number. And if you look at everything that we are, the numbers that we are considering, we have 5 numbers. So meaning that we can talk of 4-digit number, we can talk of 5-digit number. There's no problem with 5-digit number. It will always be 5 permutation 5. That's one, there's no problem with that. For me to form 5-digit number, and I'm using 5 digits, it will be 5 permutation 5. I'm using all of them. But for 4-digit number, and they have also said that what it is not just any 4-digit number, but it must be greater than 3,000. So it means 1 cannot start such a number. 2 cannot start such a number. It's only 3, 4, and 5 that can start. So I need to sort out that issue before using permutation. So it means for the first digit, I can only start with 3 numbers. So I have 3 ways. I have 3 ways for that. I can only start with 3 numbers. So I have 3 ways of filling that. Then you now have how many places to fill? I have 1, 2, 3. I have 3 other digits. 3 other digits to fill. And I have 4 letters, 4 digits left because I've picked 1 to occupy the first digit, to occupy the first position. So I need 3 more out of what? 4 remaining. That's why we have 4 permutation 3. So 4 permutation 3 will give me 24. 24 times 3 will give me what? 72. It means I can have 72 different 4-digit number. So that's for that. For 5-digit number, I have what? 120 different possibilities. So add them together. So 72 plus what? 120 will give us 192. I will not do number 3. You should be able to do that. Number 4, they said you can see number 4 now is like a double barrel. How many even numbers greater than 5,000 can be formed using the digit 1, 2, 4, 5, 6. So how do we do that? How do we do that? 1, 2, 4, 5, 6. You need even numbers. How do you recognize an even number? Yes. Can anybody say anything? We have 10 minutes more. So we may not be able to cover the whole. But I will send you the notes. For those that are not in our group, in the WhatsApp platform that we created, let me just use this opportunity to send the link, because that is where I'm going to send the material that we are using now. I will immediately after the class, I can forward the material there so that you also have access to it. You can go and practice it on your own. So I'm going to send the link now into just check the chat room. So when you check the chat room, you can pick up the link there so that you join the class. Okay. So I think I've sent that. I've sent the link. So you can just check the chat box. You can see the link there. So I'm going to forward the the questions or the notes. I'm going to forward it there. Now, so the 5,000, how many numbers, how many even numbers greater than 5,000 can be formed using the digits 1, 2, so we 1, 2, 4, 5, and 6. Now, 5,000 is how many digit number? Is a 4-digit number. So in this case now, we can't just use any one to start. 1 cannot start if you are picking 4-digit number. 2 cannot start, 4 cannot start. Only 5 and 6 can start. You know, all of them, they are 1, 2, 3, 4, 5 digits. So it means like the last one we did, you can have 4 or 5 digits numbers. For 5-digit number, we may not have much challenge. But not all of them. We can't just use all of them too like that in 5 digits. Exactly. So for 5, let's first look at 5 digits. For 5 digits, the only challenge we are going to have, because they said even numbers. What are the characteristics of even numbers? They are divisible by 2. How do you know that a number is divisible by 2? That's another question. Can anybody answer my question? I have limited time. I will have allow some of you to answer the question. But let me tell us that the last digit must be what? Must also be even. If I have 1, 1, 1, 1, 1, 1, 1, even if all of them is 1, 1, 1, all of them is, once the last digit, it must either be 0 or 2 digits. So also or even number. So that is it. So in this case now, it means only this can end, 6 can end, 5 can end, 2 can end. Exactly. You need to sort out how many numbers can end first. 6 can end, 4 can end, 2 can end, because they are what? Even numbers. So I have 3 possible ways of ending for 5 digits. So I have 3 possible ways of ending. So 3 possible ways. So after picking the head, I don't have any other problem again. So I will have used one of those 3. So at the end of the day, I have how many numbers left? 1, 2, 3, 4. I have 4. So it means for the remaining one, you know, I'm supposed to use I'm preparing 5-digit number. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Yeah. So since I filled this one, I need to fill 1, 2, 3, 4. That's 4. Out of 4 numbers remaining. So I will get 4 permutation 4. So that would be 3 times 4 permutation 4. So that would be 3 times 24, which is what? 72. That's the number of 5-digit numbers that I can have. Now, for 4-digit number, it is double barrel. I need to consider what will be at the beginning. I also need to consider what will be at the end. Exactly. What will be at the beginning? What will be at the end? So the first thing is that what will be at the beginning? Whichever one you can do first. Whichever one you can do first. So, like I said, 1 cannot start, 2 cannot start, 4 cannot start, but 5 and 6 can start. So, if 5 or 6 is starting now, for example, 5 or 6, so I have 2 ways. But the fact that 6 is also what? If 6 is starting, it means 6 cannot end. This question is somehow technical. So, but what I'm going to do now is that I will say that what? If, for example, let me assume there is only 5 that can end. Because I can't just do this one too anyhow. Because if 5 end, it means 6 cannot work. 6 can also work. If 5 starts, 6 can end. But if 6 starts, 6 cannot end. Exactly. So because we can consider 6 for both to start and to end. So what I'm going to do now is that let's assume that I'm starting, only 5 can start and 6 cannot start. So it means I have just one option. Having done that, I will now go to the back. How many numbers can end? 6 can end, 4 can end, 2 can end. I have 3 numbers that can end because they are what? They are even numbers. So it means in all, I've picked 1 here, I've picked 1 here, I've picked 2 out of 1, 2, 3, 4, 5, out of 5 numbers. So I have what? I have 3 numbers left. So I can now say that I want to pick 2 out of the 3. So I can say that here which will be what? 1, 2, okay, 3 permutation 2. Or you, yes, 3 permutation 2 left. You get it? I have 3 letters left. If I have picked this and this, I have 1, 2, 3. I have 3 left. So I can now pick 2. Any 2 to fill this position and this position out of the 3 left. That's 3 permutation 2. So I'm going to multiply this 1 times 3, multiply by 3 permutation 2. Now I've not exhausted the options I have. Now this is if 5 must start. So if 6 must now start, you know, the end and the first. If 6 must start, it means I have only option of 6 that can start. That's one option. In such a case, if I want to go to the back, I can't have 3 again because 6 have already started. 6 cannot end again. I can't repeat. If 6 must start and it must end, it means I've repeated a digit twice. So I should not repeat such a digit because 6 can come first, it can also end. So that's why I've separated 5 and 6. So in this case now, I will say only 6 can start, but it cannot end. So for those people that can end, I have only 2 and 4. So I have 2 options here. So in all, I've selected something for this, I've selected for this. Out of 5, so I have 3 left, and I need 2 more to fill the what? The middle position. So 3 permutation 2. So that would be what? 1 times 2, 2 times 3 permutation 2. What is 3 permutation 2? It's saying that 3 factorial over 1, that's 6. So 3 times 6 is what? 18. This one is 2 times 6 is 12. So at the end of the day, we are going to add 72 plus 18 plus 12. 18 plus 12 will give us what? 30. 30 plus 72 is 102. So the answer to this is 102. Thank you very much. I think we'll be ending the class at this particular point because it's exactly 7 o'clock now. I don't know how we can actually make up because we have still not treated anything. We are only ending permutation now. In fact, we have not ended permutation because we have still not discussed permutation in a ring. But because of the time, we have to stop now. So we have not discussed permutation in a ring, and we also want to discuss the concept of combination. So maybe what we'll just do is that next week, we should be treating. Okay, maybe that is what we have to treat next week. We have to finish the concept by next week. So that is it. We may not be able to treat anything about vectors again. So we have to go back to this concept because you need to understand this concept very well. So as a result, for next week, we may have to look at this concept again. So if there's any question,